Start off by looking at the difference between average or instantaneous velocity. Now, to compare the two, we might take the example of a sprinter who runs a 100-meter sprint, and we know over the time of their sprint the speed they'll be running at or the velocity they'll be running at will vary. We know at the start of the run the velocity was 0, and eventually they accelerated until they reached their maximum velocity. Now, when we consider moving objects, we know that they don't travel at their average velocity the whole time. So we can work out an average velocity by considering how long it took for a particular object to travel a certain distance. And as I mentioned, we know that the average velocity will not indicate, therefore, what the speed was at all periods in time. When we consider the instantaneous velocity of an object, we're considering at a specific instant in time what is the velocity that it's traveling at. So for example, the speedometer in a car would tell us how fast we're traveling at a certain instant in time, therefore it's indicating what the instantaneous velocity is. So we know that as the time interval for a calculation of average velocity is decreased, the average velocity gets closer and closer to its instantaneous velocity. So to determine a velocity, we've already discussed this. Some pieces of information that we need to know a displacement, and we need to know the time period in which a certain displacement has been reached. So some easy ways to determine a velocity of an object. So in this example here, we can see that we've got a bike rider and they're going to be traveling a certain displacement over a time interval, and because we know the time interval and we know the displacement, we're therefore able to work out an average velocity. Has that bike traveled at that average velocity for the entire period of movement? No. Because we know that obviously at the start it's going to be traveling slower than what it would be when it eventually reaches its maximum speed. Now, the problem with trying to determine an average velocity when the time period is quite small, if we're using a stopwatch, for example, we know that we need to be able to observe when that object's starting and when it's stopping, and therefore we're bringing in some human error. So that human error which is involved in the amount of time it takes for our brain to react and click that stopwatch is known as reaction time. And we know for humans that depending on who might be measuring, that reaction time could range anywhere from 0.2 to say 0.5 seconds. Therefore, if we are looking at the speed of runners in Olympic events, we know that the margins of difference in time that they run those certain intervals in can be very, very small, so that using a stopwatch wouldn't be a very appropriate method to try and measure that time, and therefore we need to use some type of more accurate technique to try and measure the time intervals. Some methods to more accurately measure these time intervals would be using sensors. So in an Olympic run, they use light sensors rather than using a stopwatch. Within our science laboratories, we have some motion tracks which we can use to determine the average velocity or average speed or a time interval that an object moves. And basically these work by bouncing ultrasonic pulses off of the object, and then we have some piece of machinery which can then therefore calculate the time interval. Another method for measuring an average velocity more accurately may be using a ticker timer. So last year in Year 10 Science, I think most of you would have been exposed to using a ticker timer, and basically we know that what happens is we attach this piece of paper to some object. So say I have a toy car, and this little contraption is basically printing dots onto the carbon paper, and as the object moves it threads the paper through the machine, and because we know the time interval at which those dots are being printed, we can use this information to determine an average velocity because we have a distance that the object has moved over a certain time period. To reduce some of the error involved in the calculation, we can take a number, or we can basically take a number of the recorded dots on the paper and then divide it by the particular time interval for it to happen. Another error which would be introduced when using a ticker timer, however, is that there would be some friction between the carbon paper and the machine, and therefore that could affect our measurement of time. Another method that can be used to determine the speed of something, as shown with this golf swing, we can use multiple image photography. So if we know the time interval between each of the shots, we can therefore again work out the distance moved by the object, and if we know the distance traveled in a time, we can therefore work out an average velocity. So this enables detailed analysis of complex movements such as the golf swing.